Hey everyone, welcome to the Unknowverse. I'm your host, your name, and I'm so excited to have you here. Get ready to have your mind blown with some incredible physics facts you probably never knew. From the vastness of space to the strangeness of quantum mechanics, we're about to embark on a journey that will challenge your understanding of the universe and leave you in awe of its wonders. Let's dive in. Okay, strap yourselves in for this one. We're about to embark on a journey through the cosmos that will blow your mind. Imagine you're on the most thrilling roller coaster ride, but instead of loops and drops, we're diving into the mysteries of the universe. We all know the universe is expanding, right? It's like a balloon being blown up, with galaxies as the dots on the surface moving further apart as the balloon inflates. But there's so much more to it than just a simple expansion. It's been stretching since the Big Bang, that colossal explosion that set everything into motion around 13.8 billion years ago. From that singularity, the universe has been growing, evolving and changing in ways that are both fascinating and mind-boggling. But here's the kicker. It's not just expanding, it's accelerating. Imagine driving a car that keeps going faster and faster without you even pressing the gas pedal. That's what's happening with our universe. And get this, the rate of that acceleration means some parts are moving away from us faster than the speed of light. Yes, you heard that right. Faster than the speed of light, which is about 299,792 kilometers per second. It's almost impossible to wrap your head around. Now, I know what you're thinking. Doesn't nothing travel faster than light? That's what we've always been taught, right? Light speed is the ultimate speed limit in the universe, or so we thought. And you'd be right, according to Einstein. His theory of relativity tells us that nothing with mass can travel faster than light. It's a fundamental principle of physics that has stood the test of time. But this expansion, it's not about something moving through space. It's about space itself stretching. Picture a rubber band being pulled from both ends. The points on the band move apart not because they're moving on their own, but because the band itself is stretching. It's like the fabric of the cosmos being pulled taut, and those distant points, they're just along for the cosmically wild ride. This stretching of space means that the distances between galaxies are increasing, and some are receding from us at speeds greater than light. It's a mind-bending concept, but it helps us understand the true nature of our ever-expanding universe. Alright, let's talk about something even weirder than faster-than-light expansion quantum entanglement. Imagine two particles, light years apart, linked in a way that action on one instantly affects the other. No matter the distance, you change the spin of one, the other changes instantly. Einstein called this spooky action at a distance, and frankly, it's enough to make your head spin too. Think about it. Information seemingly traveling faster than light. It's like the universe is playing a cosmic game of telephone, but with a connection speed that would make your internet provider jealous. Black holes, those gravitational behemoths that gobble up anything that gets too close, also mess with time itself. You see, gravity warps time. The stronger the gravity, the slower time flows. And black holes, they have gravity in spades. Imagine falling into one. As you get closer, time slows down relative to someone watching from a safe distance. They'd see you frozen, your descent taking eons, while you'd experience falling right in. Of course, you wouldn't survive to tell the tale, but it makes you think, doesn't it? Chapter 4. Time dilation. Your GPS knows what's up. Speaking of time dilation, it's not just a black hole phenomenon. While black holes are the most dramatic examples, time dilation is a concept that permeates our everyday lives in more subtle ways. It's a fascinating aspect of Einstein's theory of general relativity, which tells us that time can stretch and compress depending on how fast you're moving and how close you are to a massive object. It's happening all the time, even here on Earth thanks to general relativity. Imagine you're standing on the surface of the Earth. The planet's mass is warping the fabric of space-time around you. This warping affects the passage of time, making it tick just a bit slower compared to someone far out in space, away from any massive objects. The faster you move, the slower time passes for you relative to someone standing still. This is known as time dilation due to velocity. For instance, if you were to run a marathon at near light speed, you'd age more slowly than the spectators watching you. Of course, we don't notice these effects in our daily lives because the speeds we move at are nowhere near the speed of light. Now, it's not noticeable at everyday speeds, but for things like satellites, it matters. Satellites orbit the Earth at incredibly high speeds, and this is where time dilation becomes significant. These satellites are moving fast enough that the effects of time dilation must be taken into account. GPS satellites, whizzing around up there, experience time slightly differently than us down here. They are not only moving quickly, but are also farther from the Earth's gravitational pull, which means time ticks a bit faster for them compared to us on the ground. If we didn't account for this, our GPS systems would be wildly inaccurate. The difference might seem minuscule, but even a tiny error in time can translate to a huge error in position. Without correcting for time dilation, your GPS could be off by several kilometers, making it practically useless for navigation. So yeah, relativity isn't just theoretical, it's keeping you from getting lost. Every time you use your GPS to find a new restaurant or navigate through a new city, you're benefiting from the mind-bending principles of general relativity. You're welcome. Chapter 5. The Multiverse and Infinity of Views. Ever wonder if there are other universes out there? Well, the multiverse theory suggests just that. Imagine an infinite number of universes, each slightly different, each with its own version of you. In one, you might be a rock star, in another, an accountant. It's a mind-boggling concept, and while we don't have concrete proof, some physicists believe it's a real possibility. I mean, if the universe is infinite, why not infinite possibilities? It's enough to make you question your place in the grand scheme of things, isn't it? Chapter 6. The Double-Slit Experiment Light Split Personality. Let's dive into the quantum realm again, shall we? This time we're going to explore one of the most fascinating and perplexing experiments in the history of science. This time we're talking about the double-slit experiment. It's an experiment that has puzzled scientists for over a century and continues to be a cornerstone in the study of quantum mechanics. It's a classic experiment that shows the bizarre nature of light. The double-slit experiment reveals the dual personality of light, behaving both as a wave and as a particle. Basically, you shine light through two slits. Imagine a simple setup where a beam of light is directed at a barrier with two narrow slits cut into it. Now, you'd expect to see two bright spots on the screen behind, right? This is what common sense and classical physics would predict. But no, light gets weird. Instead of two bright spots, you get something entirely unexpected. Instead, you get an interference pattern, like waves overlapping. This pattern of light and dark bands is similar to what you'd see if you dropped two pebbles in a pond and watched the ripples interact. But here's the kicker. Even if you shoot single photons, one at a time, they still create the pattern. This suggests that each photon is somehow interfering with itself. It's like each photon goes through both slits simultaneously. This defies our everyday understanding of how particles should behave. It's as if light can't decide whether it's a wave or a particle, so it just says, why not both? This duality is at the heart of quantum mechanics and challenges our very perception of reality. Chapter 7. Dark Matter, the Universe's Invisible Glue. Here's a cosmic mystery for you. We know there's more mass in the universe than we can see. We call this mysterious stuff dark matter. We can't see it, we can't interact with it directly, but we know it's there because of its gravitational influence on galaxies. It's like the universe's invisible scaffolding, holding everything together. What is it made of? We don't know. But scientists are working hard to unlock its secrets. It's like trying to find a cosmic needle in a haystack, except the haystack is the entire universe. Chapter 8. The Speed of Light. Sorry, warp drive not included. We've all dreamed of traveling to distant stars, but there's a cosmic speed limit, the speed of light. Nothing can travel faster than light in a vacuum. It's the ultimate speed barrier. And while science fiction loves to bend the rules with warp drives and wormholes, in reality, breaking the speed of light would require unimaginable amounts of energy. It's like trying to outrun a cosmic cheetah on a unicycle. It's just not gonna happen. But hey, we can always dream, right? Chapter 9, E=mc2. More than just a fancy equation. You've probably heard of Einstein's famous equation, E=mc2. It's more than just a mathematical formula, it's a profound statement about the nature of energy and matter. It tells us that mass and energy are interchangeable, two sides of the same cosmic coin. This simple equation has had a profound impact on our understanding of the universe, from the power of the stars to the development of nuclear energy. It's a testament to the power of human curiosity and our quest to understand the universe and our place in it. Chapter 10. The Universe as a Hologram Reality Check. Hold on to your hats because this one's a doozy. Some physicists believe that our universe might be a hologram. I know it sounds like something out of the Matrix, but hear me out. The idea is that all the information about our three-dimensional universe might be encoded on a two-dimensional surface, like a cosmic movie projected onto the fabric of space-time. It's a mind-bending concept, and while it's still highly speculative, it's a testament to the fact that the more we learn about the universe, the stranger and more wonderful it becomes. Wow, what a journey. We've explored some of the most mind-blowing concepts in physics, from the expanding universe to the holographic principle. I hope you've enjoyed this cosmic adventure as much as I have. Don't forget to like, subscribe, and hit the bell icon for more mind-blowing content from the Unknowverse. And remember, the universe is full of mysteries waiting to be uncovered. Keep exploring, keep asking questions, and keep looking up at the stars. See you in the next video.